Our first couple of inequalities here are pretty straightforward. Our first one, we've got 5x is greater than negative 14 by subtracting 14 from both sides, which means x is greater than negative 14 over 5, or a few people wrote x is greater than negative 2.8. Either's fine. Personally, I'd probably leave it as a fraction, just one less thing to muck up when things are already hard enough. But either way was fine there. You could go a couple of different ways for the second one. You could subtract 2x to start with from both sides, and you'd end up with negative 3x on the left. I'm actually going to go the other way with this one. A couple of people did this as well. I'm going to have 8 is less than 9 plus 3x. And then by subtracting, that's by adding x to both sides. And then I'm going to subtract 9 from both sides to have minus 1 less than 3x. I'm going to spin that one around and say 3x is greater than minus 1. This avoids the step where I've got to switch the direction of the sign, even though I'm kind of doing that with that step I've just done. Really what I've said here on this line, 3x is on the open side. So 3x is going to stay on the open side here. Open side, big side, whichever way, or negative 1 is on the pointy side, whichever way you want to put that. 3x is the larger term here. And when I go and divide by 3 here, I end up with x is greater than negative 1 over 3. If you'd gone the other way, you would have ended up something like this. Minus 3x is less than 1. You divide by negative 3, which means you need to change the direction of the sign. Negative 1 over 3. They're exactly the same either way. Most of us could get most of that right. And if you didn't get 4 marks for those, you probably just made little mistakes, and nobody really made too many big mistakes with those. We've got an absolute value graph and then an inequality here for 1 mark, then 3 marks. We're going to start by sketching y equals the absolute of 2x minus 6. I'm going to start by saying that 2x minus 6 looks something like this, where I have an intercept at minus 6. However, what ends up happening here is I have that flipping up where I go into the negative. So anywhere where y is negative here, I need to get rid of. Some of you left that on your graph but left it dotted. That was fine, as long as you were very clear which one was which. What I did want to see for a mark here is that you actually went and labeled some key information. This value here is 3. You can get that by solving for where y equals 0, which means 2x minus 6 equals 0 and x equals 3. And then this value here that was negative 6 before we take the absolute becomes positive 6. So you needed those two values on your graph to get your 1 mark there. Hence or otherwise solve 2x minus 6 is less than 3. Now what we could do here, we could go dot some line in here. And that line is y equals 3. And essentially what we're looking for is where is our red less than our blue dotted line, and clearly we can see that's going to be an in-betweener. We can solve this a couple of different ways. The way I'm going to go and solve this is by looking at it and saying I know that 2x minus 6 has to be less than 3 but bigger than negative 3. And essentially what that's doing is that's using, if we looked at our original line, and we said that minus 3 was down here, that's going to be the equivalent set of solutions if we flip that up to the positive. The other way we could do this is to solve it as two different inequalities and then put them together. I think this way is actually going to produce less mistakes for us. Some of us, when we went and did this, we went and just looked at 2x minus 6 is less than 3. That's absolutely fine for one half of your solution. It's just not going to get you both parts of your solution. I'm going to add 6 to all 3 parts here. So I'm going to have 2x is therefore between 9 and 3. And by halving everything, x is between 9 over 2, or 4.5, and 3 over 2, or 1.5. And we can see that kind of makes sense here, right? This is the bit of my solution I'm looking for. I notice that both x values are positive. My graph isn't perfectly to scale, but I'm talking in about there, kind of either side of 3 as well. our graph's symmetrical at that line x equals 3, which is why those solutions are symmetrical about that number 3 as well. So 3 marks there. You got 1 mark if you went and in some way suggested that there was going to be 2 sides to the solution. Or if you just went and found one solution, you got 1 mark. Okay, if you just went and found 9/2, which is what a few people did, you got 1 mark for that. If you then started to solve that using both sides, then you got 2 marks. Also, if you went and found both solutions but didn't put it together, pretty sure I gave that 2.5 marks. But to get your full 3 marks, you need to say it was in between 9/2 and 3/2, written in this way as well. That's the correct mathematical way to write our solution there. We've got our quadratic inequality here, which we solve in exactly the same way as a quadratic equation, except that our solution is not going to be just 1 or 2 values. It's going to be a set of values with 1 or 2 boundaries. So if we have a look here, I'm going to factorize my left-hand side. I'm looking for numbers that multiply to give -20 and add to give 8, which is going to be x plus 10, x minus 2. 10 minus 2 is positive 8. 10 times -2 is -20. So far, the fact that it's inequality means absolutely nothing to us. Now, this is where that changes a little bit. My 2 critical values here are -10 and +2. Okay. Now, that doesn't mean that my answers are -10 and +2. So if you went and factorized that and solved it, I think I gave you 1.5 marks if you solved it that way, like a quadratic equation. But you needed to actually go and draw a sketch here. And it can be a pretty rough sketch, something like this is absolutely fine. And we're looking for, where is this curve below the axis, below the x-axis? We're talking these values in between here, which means my set of solutions is x is between 2 and -10. The other thing you could do here is you could test 0. Okay, if you went and if you go let x equal 0, you're testing to see whether our solution is between 2 and -10 or outside 2 and -10. And what happens here, we'd get 0 squared plus 8 times 0 minus 20, which is just -20, is less than or equal to 0. That's true, which means that 0 is part of our set of solutions, which means it's going to be in between, not outside. If we found that to be false, it would mean that 0 is not part of our solution set, which means we would say it's greater than 2, or less than -10, but not the case here. To get the full 3 marks, you did have to go and write your solution that way. If you didn't draw a graph, or you didn't substitute x equals 0, and you could just recognize that it was an in-betweener, not a right and a left example, then you could still get 3 marks. You got 2 marks if you could factorize it and tell me that it was going to be a set of solutions, but you had the wrong set of numbers. Okay, if you just went and found the values but didn't present it like an inequality, you were going to get penalized a fair bit here. Here we've got something where we have an unknown in the denominator, so we have to multiply it by the square of the denominator to ensure that we're multiplying by something positive, not something that could be positive or negative. X plus 4 could be positive or it could be negative, so we've got to multiply by the square of that. So our first step is to say I'm going to multiply by x plus 4 all squared, and I've still got my 5 over x plus 4 is less than or equal to 1 outside of x plus 4 all squared. So I've multiplied both sides by x plus 4 all squared. Now what I'm looking for when I go and factorize this at the end, I'm looking for x plus 4 to be part of my solution set. So what's going to happen on the left here, the squared and the denominator go. The 1 here is kind of irrelevant. We don't need to take that into account really. So I've got 5 outside of x plus 4. 5x plus 4 is less than or equal to x plus 4 all squared. Expand the left, I end up with 5x plus 20. And I expand the right, I end up with x squared plus 8x plus 16. I go and tidy all that up. I'm going to move everything to the right-hand side and then go and switch both of those. I just don't want to muck around with x squared being a negative, but we can do that either way. Most of you decide to keep x squared positive. A couple of us took x squared to the left-hand side and made it negative, and then switched the direction of our inequality by dividing by -1. Either way is fine. So I'm going to have 0 x squared plus 3x minus 4, which means x squared plus 3x minus 4 is greater than or equal to 0. Now that's again that reduces down to a quadratic inequality, and we're left with something that's going to factorize. So I'm going to, if I factorize that, I'm going to have x plus 4 and x minus 1 is greater than or equal to 0. Now, when I go and graph that one, I end up with something that looks like this. It's -4 and +1, but this time it's an outie solution. Okay, it's an outsider. I'm looking for in this direction, and I'm looking for in this direction. For the solution here, we end up with x is less than -4 and x is greater than or equal to 1. And if we have a look at our graph here, if we're trying to graph y equals 5 over x plus 4, it means we're going to have an asymptote at -4. And a graph that looks something like this guy. It shouldn't be quite so flat over here. That'll warp things a little bit. And what ends up happening here, we've got our line 1 here, somewhere like this. Okay, and so what we're saying is here, where is our red line above our blue line? Well, it's all these values here, and then it's all these ones over here as well. Okay, and of course this is -4, and where those two meet is +1. So it's greater than +1 and it's less than -4, written in the appropriate mathematical way. You could use a graph to do that. Nobody really did that. A couple of you drew a hyperbola to represent this, but you probably didn't use the graph to actually solve it. For our 3 marks here, if you went and recognized you had to multiply by the square, with the square of the denominator, that was going to get you 1 mark to start with. If you then were heading towards your answer and got to a quadratic, that got you 2 marks. To get the 3rd mark, you did need the solution written in the correct way. If you just went and multiplied by x plus 4 to get 5 is less than or equal to x plus 4, that just got you 1 mark, because all you're going to find there is this solution here. Okay, the one at +1, you're going to miss the one at -4. Okay, so that was where the 3 marks went. Our first question in the graphing section of our exam here, the things we're looking for when we're drawing a sketch, any intercepts, x-intercepts, y-intercepts, any asymptotes, there's none here, and the general shape of our graph. So if we have a look at this, we've got fx equals x squared minus 25. I'm drawing a parabola, so I'm going to have a y-intercept of -25. That's my first key feature. I have x-intercepts of +5 and -5. And my overall shape here is that concave up parabola. If you went and drew a parabola, that was going to give you 1 mark. If you went and drew a parabola and had some of those intercepts correct, that was worth 1.5 marks. But to get the 2 marks, you did have to have both the x-intercepts and the y-intercept as well. Other details on a graph as well: label the origin, label the x and y axes, draw it neatly, draw it with a ruler. Those are all just sort of basic things we should be doing as well. We're talking about a reciprocal function here. So for what values is 1 over fx undefined? So what we're saying is, where is 1 over x squared minus 25 undefined? And what does that mean? Well, that means, where do I have a problem with the denominator? And where that problem occurs is where this denominator is 0. So that means we're x squared minus 25 equals 0. On our original function, y equals fx, that's good to go. That's just an x-intercept, and there's two of them. But when we're talking about the reciprocal function, wherever I have an x-intercept, that's where I'm going to have an asymptote because my reciprocal function will be undefined. And that occurs at x equals 5. So we've got x equals plus or minus 5. Some of you went and just said, oh, x squared minus 25 equals 0, so therefore x equals 5. You've missed the negative solution. It'd make drawing your graph hard. I think one or two people actually went and found that it was just positive 5 here, but then on the next part, when they were asked to sketch the graph, they did it very well. But you had to acknowledge that there was two different values for which our reciprocal there is undefined, which is going to be our asymptotes on our next graph. Now we're after sketching our reciprocal function here. I've taken the liberty of including our two asymptotes to start with of positive 5 and negative 5. That's where my reciprocal function will be undefined. Now, working on our basic idea that wherever our original function, wherever our parabola was negative, our reciprocal will also be negative. And what ends up happening there, our y-intercept becomes, it was negative 25, now becomes negative 1 over 25, really, really small there. And what starts to happen, we end up with something that looks like this, our concave down parabola in the middle. It's not really a parabola because what it does, it actually gets very close to those asymptotes but does not cross them. And what's going to happen up here is we end up with our two hyperbola. It shouldn't be that pointy there. Our two hyperbolic type shapes there. And that's because what happens in these parts, well, this is where our original function gets really, really big. Let's pretend we've put in x equals 15. Okay, 15 squared is 225. We go and take away our 25 because it was x squared minus 25. We end up with 200. Well, 200 is quite big. 1 over 200 is really, really small. Okay, and in the same way, when we get to these parts here, well, this is where x squared minus 25 was getting really close to a value of 0 because let's say x might be 5.1. Well, 5.1 squared is just a little bit bigger than 25, which means when I take the reciprocal of that, I end up with something really, really big. But they are both positive. They are reflections of one another on the left and the right there. And then, of course, our parabola in between. The reason what's happening at these parts is because x squared minus 25 is getting really, really close to 0, but it's negative. And when I take the reciprocal of something very, very small that's negative, it becomes really, really, hope you're repeating this with me, really, really big. It becomes very large and gets really close to a negative infinite value. So for our couple of marks there, you did need to show the intercepts and asymptotes. I haven't written mine on there, but I've talked about it. That y-intercept is negative 1 over 25. You did need to show that. There's no x-intercepts here, so you couldn't show those. But you did need to show that we had the asymptotes, the two asymptotes, and that negative 1 over 25. That was worth a mark. You also then needed to show that you had the parabolic shape in the middle of the asymptotes and the hyperbolic shapes outside there. I mean, in some cases, I gave you half a mark if you just showed a hyperbola somewhere, recognizing, well, it's a reciprocal, so it's going to have to be a hyperbola somewhere. That was worth a half mark, depending on how well you did that. But for the full marks here, you had to go and have all the details I've shown here. We've got a graph y equals fx here. It looks like it might be a cubic. We've got 3 x-intercepts. We've got a y-intercept. We don't know what it is. And we've got a couple of points shown there as well. So we're asked to sketch the absolute value of fx. So this one's pretty simple. And I hope you found so in the exam. Most of us did this one pretty well. I'm going to trace over this. We had something that looks a little bit like this. So essentially what happens anywhere I have a negative y value with a positive y value. So what happens is that all my negative values are flipped up in the x-axis. But I do actually have to show this point here. I wanted you to show that point here. That becomes 3, 3. Should be at approximately the same height as this one here. Mine's possibly a little bit too high, but it's at approximately the same level here. We also need to state the domain and range. Our domain here is all real x, and our range is all real y. Y must be greater than or equal to 0. I think one or two of you put y is greater than 0. Now, y can actually equal 0 here. It does, in fact, do that 3 times. Okay, y can be 0. It just can't be less than 0 here on an absolute value. So the domain and range, they were worth a mark at the end. Your in some way showing the general shape was important. I took off half a mark as well if you didn't show that 0.33 because it was pretty clearly labeled there. And if you didn't have to rewrite -3, 2. In fact, I've just realized I've made a mistake earlier. This 3, 3 here should be a little bit higher than the other point over here. Because it's at 3, not 2. But again, it's as long as it's a little bit higher, that's fine. And you did label it. That was important to get the full 3 marks. We're going to sketch a root function, and we've got 3 marks to do so. We're given some information as well. We're told about where the curve has x-intercepts and a point that it passes through at 1, 4 as well. So straight away, what I can do, I can neglect these values. Okay, all those guys down there, they can be ignored. That's not going to be part of my curve. Now, the other thing we know is that wherever I have an x-intercept on my original function, I also have an x-intercept on my root function because root 0 is still 0. And the other thing, if I look at this 0.14, it's mentioned in the question, which says to me it's important. I should acknowledge it in my solution. Well, what happens here? At x equals 1, I take the square root of 4, which is 2. Got another point here. The other thing we can do if we're trying to plot out some points here is wherever my curve passes y equals 1, passes through here, my root function also passes through, because the square root of 1, much like the square root of 0, remains the same. Square root of 0 is 0, that's why we have x-intercepts at the same place, and the square root of 1 is 1, which is our 3 locations where our root function meets our original curve. To acknowledge here, a nice easy point to map out is if I look at this point up here at 4, 4, well, the square root of 4 becomes 2. So I've got something that looks a little bit, I've got something that looks a little bit like that. And I end up with my curve flattening out there. It's still increasing. I've got my turning point here at 1, 2. Should acknowledge that. I should also acknowledge this point 4, 2. Okay. We don't know these values here. We don't know these values where the x values where our original meets our red, where our original meets our root function. We've got one at something like 0.1, another one at like 2.3, and another one at about 3.6, something like that. So we don't know exactly what they are, but as long as we're clearly showing that they are there. So that was what you needed to do for your 3 marks as well. Overall shape gave you 1 mark, and ignoring the negative values for y, indicating where the x-intercepts were. Some people just went and did something like this. They just sort of went and said, oh, a root function kind of goes sideways. Depending on what point you labeled, that got you 1 mark, but it definitely wasn't going to be good enough to get you a couple of marks there. You needed to show that it went down and then back up again. And if you sort of were a little bit off in terms of where you were meeting your root and your original were meeting one another, that cost you as well. But overall, this was done pretty well. I was really pleased with how the root function was drawn. The domain and range for our root function here, pretty straightforward. some nice easy marks towards the end of the paper. Our domain is x is greater than or equal to 0, all real x. Okay, all real x is greater than or equal to 0, and our range is all real y, where y is also greater than or equal to 0. Essentially, our curve is existing in this quadrant. Okay, our curve exists in this quadrant here. Our root function curve from the previous slide. So therefore, it's where x is positive and where y is positive. But also, we do hit the x-axis a couple of times and the y-axis once. So we do need to acknowledge that it's not just greater than 0 for both, but it's greater than or equal to 0. Last thing you needed to do here was acknowledge one similarity and one difference between the curves y equals fx and y squared equals fx. So if we take our root function looking something, its general shape is sort of like that. Okay, I've not shown any of the key details on there. One similarity is you could comment on the domain and range. The domain of y equals the root of fx and y squared equals fx are the same. Both x is greater than or equal to 0. But the range, however, changes. The range now becomes, I'll do this in a different color, which some of you did nicely in your exam, becomes something like that. Okay, a lot of people talked about the difference was that there was a negative component for y squared equals fx. That was good for a difference. The similarity, the biggest thing you really need to comment on is the domain stayed the same. You could say something like they've got x-intercepts at the same place, or they've got they've got the same domain is probably the way I would have gone. But as long as you're in some way acknowledging that there was, for your difference, that there's either a reflection in the x-axis or that y squared equals fx includes negative values for y, that was worth a mark here. The last statement was kind of a hint. You may use, means you probably should use your answers from 1 or 2 to support your answer here for a mark. Overall, I was really pleased with how everyone went on this paper, considering it was interesting times in doing this under slightly interesting circumstances, and the graphing topic's really, really hard. The questions within this topic were not that hard, but there's no easy questions. So I was really pleased. Hopefully you've made it this far and thought about the things you've done well and the places where you might need to do a little bit more work. Overall, I would say our graphing still needs to improve a little bit. That wasn't done quite as well as the inequalities, but overall, all things taken into account, really, really pleased with how everyone went. Well done, guys.